Hi everyone and welcome back. In the last video we took a look at basic identities, and in this video we're going to take a look at an example of how we can use them. First thing though, before we get started, I want to go through the basic identities that we have listed on the right here, and I want to make really clear that some of these look like what you've seen in algebra, but some don't. So you have to remember that basic identities, the ones that are listed here on the right, are specific to Boolean logic. Number one, x plus 0 is equal to x. That one makes sense. That's something that you've seen in algebra. Number two, x times 1 is equal to x. Again, that makes sense in terms of algebra. Number three, x plus 1 is equal to 1. Well, that would be true if x is equal to 0, but no other value would make that true. So that one doesn't seem to fit what we've followed in algebra, or what we've learned in algebra. Number four, x times 0 is equal to 0. Again, that makes sense from what you've done in algebra. Number five, x plus x should be equal to 2x if we're talking about regular algebra. But in this case here, x plus x is equal to x in Boolean algebra. Number six, x times x is equal to x in Boolean algebra. In regular algebra, we know that x times x is equal to x squared. So just a reminder that when you're using basic identities, they are different from regular algebra. We need to know these ones specifically to do Boolean algebra and to simplify Boolean equations. Let's take a look at the example that we have here. We've got a couple of gates. We got inputs A and B. We've got output Z. If we were to write the Boolean equation for this, we would have Z, the outputs, equal to, well, we can see that A and B both go into this AND gate here, and AND is represented by multiplication. So I could represent that as AB. Then the output goes into this OR gate. We've got A that also comes in here, and so we get AB ORed with A ORed with AB, so it looks like this, recalling that OR is represented by the plus sign. Then what I can do is I can take out a common factor. I can take out a common factor of A, and what I'm left with is just B plus 1. Then taking a look at my basic identities, it looks very similar to number three. X plus 1 is equal to 1, or B plus 1 is equal to 1. So what we have here is just 1. And then we have Z is equal to A times 1. And from basic identity number 2, if we multiply by 1, that's just itself. So it just gives us A. So really what we've determined here is that simply, even though we have this circuit here, it reduces down to simply the circuit that whatever A is, that will be the output Z. So we can simplify circuits using the basic identities to come up with the simplest circuit possible. That's it for this video. Thanks for watching. We'll see you next time.